the first presentation, I will continue with the first presentation on ventilative cooling in the Danish regulations. And the background for addressing ventilative cooling in Denmark is that we can see that the development towards what we can call near zero energy buildings has resulted in an increased need for cooling, not only in the summer period, but actually most of the year. In this year, 2015, actually 10% of the built area is built according to the expected regulations for 2020. So this means that we have a number of, and will get in the future, quite a lot of experiences with this building type. And so far we can see that too high indoor air temperatures are one of the most reported problems in the post-occupancy studies in these near zero energy buildings. You could say in the design of these buildings there has been a lot of focus on reducing the need for heating, which typically has been the main energy use in buildings in Denmark. So a lot of effort on insulation and air tightness. But as we can see now, there is also a strong need to address the cooling. And as the climate in Denmark usually has temperatures below comfort level, there is a large cooling potential of the outdoor air. Why do we experience these new challenges in the zero energy buildings? I think one of the main reasons is that cooling has never been a big issue in Denmark due to our climate. So this means that it's probably underestimated and not given enough focus in the design process. All the efforts is on reducing the need for heating, by insulation, air tightness, heat recovery, and so on. The other aspect, especially for residences, is that the design methods are very simple, also very simplified. We have a mean monthly calculation tool, which is averaging heat loads in time and space. And also this method does not give a very good correlation between, you could say, cooling need and overheating risk. And then finally, there are not many, you could say, standard solutions especially for residences in Denmark. Users have very limited experience in handling overheating, so they do all the wrong things. And many of the solutions that are applied in the buildings today are what we could call one of a kind. And these, of course, also always have some, you could say, challenges in the adaptation to practical use. Just a few examples on what happens in some of these buildings. This is a low energy building, a small residential single family house. And what you can see here is that if you look at you can see on the charts the time during the year where the temperatures are within certain limits according to different classes. And you could say that it's actually for the living room, which is the right chart, actually 44% of the time during the year the temperatures was above 27 degrees. So this means this living room has considerable challenges for overheating. The next year, in 2011, internal shading was installed, and also users were given some guidance on how to, you could say, apply window airing, apply shading to improve their comfort level. And what you can see is that they actually managed to decrease the you could say the periods with overheating from something like 44% to something like 6% instead. Of course, the summers was not the same, but you can see this is a very dramatic change. So sure, there is a possibility to avoid overheating problems if you apply the right technologies and apply them correctly. Another example is from renovation of existing buildings. Here is just a few four examples of single-family houses that were renovated. This is say in Danish, but it gives you an impression on that these houses were renovated in different ways. Some only changed windows and heating systems. Others also was improved the insulation of the roof and the walls. While and one was, you could say, completely renovated. And this figure here shows monitored temperature levels in the living room during a summer period. And you can see especially one of the houses which have quite large glazed area towards the south. The hours for temperatures above 26 and 27 degrees was quite a lot during the summer season. So it's clear that in this case, the overheating problem and the cooling need was not addressed in the design of the renovation. But ventilative cooling can be an efficient solution in Denmark, and especially also because cooling is needed not only in the main or the peak summer period, but actually also in fall and spring. There is a large potential due to low outdoor temperature. But if you see on the application in a Danish context, the application of ventilative cooling is at a very low level in residential buildings. It's considered difficult to evaluate, and there are a few technical solutions available. It's mainly today based on manual window opening, and only very few are automated. If you look at on the office buildings, ventilation is typically designed for indoor air quality criteria, and even though it is used in the standard way for cooling, the benefit is often limited due to the fan energy use. And if we look at the application of natural and hyperventilation in offices, it's only used in a very few cases. In Danish building regulations, it is generally allowed to use or take into account the effect of ventilated cooling, but we don't have any guidelines or recommendations on how to do it. There are some requirements on thermal comfort, both in relation to acceptable air velocities, but also in relation to acceptable indoor temperature levels in residences. So buildings, the temperature are not allowed to exceed 27 degrees for more than 100 hours per year and 28 degrees for more than 25 hours per year. And in our compliance tool in Denmark, there is also a simplified method available to document that you are within the temperature levels. The challenge here is that this methodology is based on a mean monthly approach, and the reliability or the accuracy of this methodology could be better. The Danish compliance tool B10, you have to demonstrate that you are below the indoor temperature levels stated. But of course, as I said before, it's a mean monthly method, so the prediction of cooling need and overheating risk is not very accurate. You can also include natural ventilation or the effect of natural ventilation of cooling in the buildings, but as there are no recommendations or guidelines, you have to be, you could say, quite competent and clever to be able to do it in a proper way. You can input values for ventilated cooling, separate values for day and night. But yes, as I said before, the recommendations on how to determine these values are not there. It's therefore quite simple to use for mechanical systems, but if you want to apply natural ventilation, it is more difficult. And of course, the cooling need is typically calculated for the whole residence. Although in order to comply with the temperature, you need to calculate the risk of overheating for a critical room. If you look at ventilative cooling in the Danish ventilation standard, it specifies requirements also for ventilative cooling, expressed in different ways, free cooling, night cooling, passive cooling, and so on. But it does not give any guidelines on how to design the system, how to calculate the cooling performance, or how maybe increased velocities can be achieved and documented. So if you look at the status of ventilated cooling in the Danish regulatory context, they support the use of ventilated cooling in words, but there are not much guidance on how to do it. And the Danish EPBD compliance tool, which is based on a mean monthly method, I think do not support a fair evaluation of ventilative cooling because the methodology is not reliable enough. And therefore, ventilative cooling is also considered to be difficult to work with as a designer or an engineer. There is too little guidance and too large responsibility. So therefore, natural ventilative cooling is not widely used in building designs. If you look at the future, you could say the future looks promising because there is an increased awareness about the risk of overheating and the need for improving the summer comfort. So this means there is also an increased focus on developing improved tools for this reason. And therefore, there is a need for better methodologies for determining the cooling effect and for determining the effect of nighttime cooling, ventilated cooling, and so on. Thank you.